All right, good morning, everybody. A little chilly in here. It's officially sweater vest season, so we've seen a lot of these in the next few months. I'm going to review a little bit of Chapter 5. We're going to finish Chapter 5 today, and there's going to be two assignments. One where I'm going to ask you to design an Access database on your own. I kind of did most of the design for you, but you have to make it happen in Access. And then the Chapter 5 quiz. And I made them all due for, I made that both those assignments. We'll go through those. Both those assignments due next Wednesday. So basically a week from today. So I know you have break on Monday and Tuesday, so why? But you don't have to wait till Monday and Tuesday to do it. You can do it for sure. This isn't going to take you that long. You can do it before break begins. But let's talk a little bit about what we're learning with databases. So a couple things. What do databases consist of? What do databases consist of? There are three things we say databases consist of. They are, go ahead. Metadata, right. Data about data, right? So we entered metadata and we said, hey, in this field, we put an M for male and M for female. We describe the data, data about data. That's very good. What else comprises a database? Mr. Kane.
Relationships.
Very good. We relate the things together. What's beautiful about relational database model is, very elegantly with two tables, we can, and these relationships, we can store very complex situations, right? So relational relationships, and the third one obviously is tables. And when we talk about it, there's a hierarchy. So databases obviously consist of relationships, but under databases we have these things called tables. And under tables we have rows, and under rows we have columns or fields. Okay, these fields consist of characters. And as we know, in databases or in anything computer, characters, everything is stored in binary, sometimes called ASCII code, but it all comes down to ones and zeros, and these are called rows or records. And tables can also be called files. So if you think about it, that is the structure we use. That's the dominant structure for every database, and it's called the relational database model. It's used in Oracle, IBM 2, Access, DB2. It's used in and also Microsoft Access that we use. Okay, so that's very important. So we saw those things come together. When we built tables, and we built tables ourselves, there was always a unique column or columns that identified a row, just like you have a student ID or a driver's license number or a social security number. What do we call that in the database world? That key. It's called a primary key, right? The primary key is the column or set of columns that uniquely identifies a row in a table. And we use that to build relationships. And when we refer to it from a previous table, from another table, we call that key what? Because it points to the primary key in another table. We have a primary key and a foreign key. Very good. Okay. So these are some of the concepts we talked about. And databases and database management systems are a little bit different. Okay? A database is, as you guys identified, the tables, the relationships, and the metadata. The database management system is the software that goes around it. It allows us to read, insert, modify, and delete the data. Now, when we interact with the data, we run a question. What do we call that question? We say, I want to see all the juniors that are from Cambria County that have a GPA greater than 2.5. What do we call that when we talk to a database? We call it a query, which means it's a question, okay? And the language that databases use isn't Spanish, isn't Portuguese, it's not English. What is the language that we use to communicate with the database? And if you take the database management class as an MIS major, you'll learn this in detail, but we don't learn this in detail. What was the language? What's that? It is code, right? It becomes code, but what do we call it, Mr. Kane?
Is it structured query language?
It is. It's SQL. A lot of times they call it SQL or SQL, okay? SQL or structured query language is how we structure a query to a database, and it in turn gives me back information, right? So that's an important component, okay? And it looks like this. This is an insert SQL statement. when we retrieve information, it's called a select statement. We don't have to know that code, but we do have to know what it is. Okay, it's an international standard. It's used by most popular database management systems. And if you're an MIS major, and I've had MIS majors go on job interviews, and they tell me, they ask me to write an SQL statement, right? That might be part of the interview, right? A simple SQL statement so that you can show you can interact with the database. Okay, so a couple other things. So we have databases, we have database management systems, which allow us to do software. But we're kind of going from, think about it, hardware, software, data, procedures, people. Hardware is, like you're storing on our physical device. Software is a database management system. Data goes in. But we still need it in a format that we can interact with people, right? And the format we used to enter data in our database wasn't nice, was it? It was kind of a table, and we tabbed. It was like an Excel spreadsheet. It's not an application-ready way to interface it. So when we talk about database applications, on top of that, database management systems apply certain things. One of the things is a form. Okay? A form, as you guys know, everything you fill out when you put in information into a website, a form is just a very nice way to view data, insert new data, update existing, and delete existing data. Instead of using tables, a form is like an interface that a person can see and interact with it. Forms can have, different designs, different information. Reports are a structured presentation of data using sorting, grouping, filtering techniques. And we're going to see this in Access. I'm going to show you this in a moment. Queries we saw are just questions searched based upon data values, and application programs provide the data. So let's look at an example. If I go to that database that we built, okay, and you may have it, you may not have it, but the database that we built the other day was our ticket database. And if we want to enter information into entertainers per se, we can do that. Okay, we could do that kind of in a table format, which isn't the nicest way to interface with a person, right? It's kind of ugly. So what we can also do is we can create in this database management system, we can create a form, a structured form where we can enter, delete, retrieve data. And I'm going to use the form wizard to do that because it's easier. So I'm going to click on Form Wizard, and I'm going to say, okay, what do you want on this form? Well, I can pick one field, like just entertainer ID, or if I hit the double arrow, it's going to bring over all the fields. So I'm going to want to see all the entertainer fields on here. I click Next, and it says, what's the structure of this form? It can be columnar, tabular, data sheet. I'm going to say a column form. I click Next. And I'm going to call this form Entertainers Form. And I'm just going to click Finish. So now, instead of me interfacing with that data as a table, like a spreadsheet, which isn't the nicest interface, you see now I built this form that sits on top of it. If I want to add data to it, I can still do that, but instead of I'm on record 1, here's record 2. If I want to add a new or blank record, I can put something here, test, entertainer fee, $900, test, I'll put in here, and then here's my drop down. So this is more like what you're accustomed to, when we talk about interfacing with data, okay? So we can design forms. The other thing we can do, okay, we designed a query, you saw that, but we can also design reports. Okay, so let's go over here to a report wizard, because now if I look at the data, it comes back, and it looks like this, like a data sheet. Okay, but if I want to design a nice looking report, I can use the report wizard. So let's say I want to bring over information about events, and I want the event date, the event name, and then I want, as along with that, I want the venue name, and let's say the entertainer name. So that's all I want on my report. So I'm pulling data from 3 different tables. I click Next. It says, how do you want to view your data? Let's say by events, that's fine. And do you want to add any grouping? No, I'm not going to add any grouping. I don't want to sort my data. I'll put it in tabular format. I click Finish. Okay, and it runs a report. Okay, so now it's not a table. This is something that is a report that I can print. I can export to a PDF. Okay, so this is something that sits on top of the database management system that allows me to go from the hardware, the software, the data, to the people component. Okay, so forms and reports, which I don't think bears a whole bunch of more information. Let's go forward. Okay. So this kind of shows us where things go. So we have a database that consists of tables, relationships, metadata. We have a database management system that sits on top of that. That's software that allows us to interface with it. And then we have database applications. Applications that use the data consist of forms, reports, queries, application programs that do things. Okay. And users, this is how we typically access databases, through some kind of network. And that's some examples of queries and those kinds of things. All right. So the book has a whole section on what's called development models. We're not going to do those. If you take database management class, MIS102, you will do database models, but I don't think it pertains to this course. A couple things that I do, the last thing that I do want to talk about is something called normalization. Okay? Normalization is the process of converting poorly structured tables, poorly structured information into normalized tables, tables that are at their most broken down. Okay, now, give you an example. This is an example of a poorly designed employee table. Okay, so for example, here's data. This is Jones. He was hired on February 1st. There's his email. There's his department number and his department name. And here's the 4 pieces of data. If that department name changes from accounting to accounting and finance, we have to go and update every record for every employee that is a member of the accounting of Department 100. So what's wrong with that? So if the department name changes, we have to change it for every employee. What would we prefer to do? So why is this a poorly structured table, I guess is my question. Why is this a poorly structured table? Sarah? Okay. We only want to have to change it one time. Because here's the thing. If I have to change it 50 times, right? What if I change it 45 times? So now I have 45 accounting and finance and 5 accounting, which is wrong. Now I have what's called data integrity issues, right? Data integrity issues is that the data is garbage, right? It's not the same. It's not standardized. If I built this as a normalized table, it would look like this. I would have the employee table, and I would have, let's see, it looks like the name field, the hire date field. There's obviously going to be an employee ID. I guess I should have put it in there. And I would also have a department field. So it'd be department number, department name, okay? And department number would be over here and would point to this department number. This would be a primary key, this would be a foreign key. So if the department name changed under this structure, how many places would I have to change it? Just once, right? That's creating normalized tables. We break it down into its individual elements. People, by nature, say, I'm going to store everything as a list structure. So they try to store everything in one row about this employee. But normalization is taking those fields and breaking them on their own separate tables, right? Every entity gets its own table. And that's what the process of normalization, creating single theme tables, themes about one thing, okay? Summary of normalization, represent each entity with a table. Each entity identifier becomes the table key, the primary key. Entry attributes become table columns. Normalized tables is necessary, which all it means is breaking them down finer and finer. We represent relationships using foreign keys. and many of the many relationships we can add with another table. Okay, so that is the process of normalization. And that is really the only information that I'm going to cover in Chapter 5. I think we got the basics, what a database is, what a relational database is, what SQL is, and the process of normalization. What I really want you to be able to do, though, is apply this to understand this. So the assignment that I have designed, I want to take some time and review that today, is under assignments, and it is under MS Access assignment. It is due next Wednesday, October 21st at midnight, so you have basically a week and several hours to complete it. And I would like you to open up this document, and this document has the details of our assignment. So we want to, in Access, build a database that consists of 2 tables. This is not a very robust database, but it is using some of the things that we learned in Access. The 2 tables are students and residents. Okay, so it's going to store the residents like dorms. Okay. In the student table, I want you to have a student ID that is the primary key, and then I want you student first name, student last name, student address, student city, and you'll see the specifications. This is what we call in the technical world a specification document. I'm telling you to design this database. Here are the specifications. So some of this is pretty easy. Now, a couple things. When we get to home phone and cell phone, I want you to put an input mask on that. You guys remember when we dealt with the cell phone, we said go to input mask, and we said use the mask, area code, so I want to make sure you do that. Twitter ID, GPA is a number, work study income is currency. Gender, I want to be a combo box with the option M or F. Okay, so that has to go down to the lookup tab. Resident ID here is going to be a foreign key that points to the primary key of resident ID here. So John Miko lives in Lewis, so this should be the resident ID for Lewis, right? In the residence table, we want the residence ID, the name of the residence, St. Louis Hall, Agnes, Jones, Giles, whatever it might be, the build date, and the capacity, okay? Now, I want you to notice in student table, there are 2 fields, 2 columns that I'm not specifying, but you have to come up with fields of your own. So you might say, well, I also want to store this information about a student. I don't know, height or weight or whatever makes sense. Okay, major. I don't think we have major. But you have to specify what other attributes we might want to store about students. So 2 other fields. Okay, that's on you. So we're going to build this database. Now I want to talk about the process of doing this. What comes first? What comes first when we go into Access to build this database? We have to build the database itself. We do what first? Tables, relationships, enter data. What goes first? We build the tables, we build the relationships, and then we enter the data, right? Just like we did when we did the ticket database. So a couple of things that go along with this. Items should be done in the following order. Build the tables, build the relationship, enter the information. When building the relationship, the link between the 2 tables should be one-to-many link, and the following thing should be set to on. And we check that box in forced referential integrity so that we have to have a residence hall exist for John Miko to be able to live in it. Once the table is built, please enter at least 3 residences, so 3 dorms, and at least 5 students, right? So you have to enter, so every student has to live in a dorm, right? Like they have to, one of the 3 dorms that you build. The assignment should be completed and saved. The file that you're going to send me has the extension ACCDB, Access Database. So wherever you put it on your desktop, you need to attach that to the assignment on Blackboard and submit it electronically. That way I can tell if you created your own or if you copied someone's database, right? Because it has timestamps and things embedded in it. So you have to submit it electronically. This is due by Wednesday, October 21st, 2015. Now, if you weren't in class on Monday to see me go through that database, or I went through things too fast for you, what resource do you have to get this done? You have the lecture capture of me going step by step through a similar assignment. It is on Blackboard under 2015 YouTube lecture captures. And I think it's, what was that, October 12th. And it says access lecture. So please, watch that if you're struggling. If you're also struggling, you can come and see me as well. So that is one assignment due next Wednesday at midnight, all right? The other assignment is the Chapter 5 quiz. Now, when I went through the Chapter 5 quiz, it is, it's a test bank quiz, but I got rid of a lot of the questions because we didn't go through a lot of the sections of Chapter 5. So the Chapter 5 quiz is out here. It's available now. It only consists of, it's a pool of questions. It's like a pool of 30 questions. But in each occurrence, you only get 10 of them. And you can take it up to 3 times. It's multiple choice. It's timed at 45 minutes. That is also due to be completed by next Wednesday, October 21st at midnight. Okay? So that concludes Chapter 5. In lieu of starting Chapter 6, we have about 25 minutes available today. I do not want you to leave. What I would like you to do is get out your laptops and start the database assignment so that if you have struggles, I will be here and I can help you do that. Okay, so this class is turning into somewhat of a lab today. All right, so please get out your laptop and start that assignment.